Good morning, my name is Kushi and I am a student of class 12. Today we are going to study chapter number 9, Ray Optics and Optical Instrument. We will start from very basic according to term to syllabus, that is refraction and its laws. After that we will study refractive index, and after that we will understood what is the concept of TIR, that is total internal reflection. So we will start from refraction topic. So this is refraction. Now what is refraction? The first question. So refraction in simple terms, it is the phenomena of change of path of light when it propagates from one medium to the other medium. Or we can say that it is the phenomena of change of speed of light when it passes from one medium to the other medium. If we see in diagram, what is it? So this is interface. This is interface. Now what is interface? Where one medium ends and other medium starts. That is the point, or that's that line. So this is interface. We call it interface. Now let's suppose here that a line is incidenting here. Okay, so we are gonna draw a normal at point where the line is incidenting to the interface. This is a normal, we represent it by n, capital N, and it is always perpendicular to the interface. This is incident ray. And now this is, let's suppose this is air medium. Obviously it is rarer medium. Now what is rarer and what is denser medium, I will tell you right now. And this is glass, let's suppose. By example you can understand what is denser and what is rarer medium. In simple terms, rarer medium is in which light has more space to travel. There are less particles in that medium, so it has more space to travel. And in denser medium, there are so many particles which are combined to each other, or there is less space for light to travel. So we can see it by example also. Air is obviously rarer medium. We are also in that medium too. Around us is only air, not glass. And glass is denser medium. So when a light incident on an interface, when a light travels from rarer medium to denser medium, it bent towards the normal and it changed its medium. So this is called refracted ray and this is called incident ray. This is called incident ray. And this is called refracted ray. It will make incident ray with normal make angle of incidence, and refracted ray with make angle with normal is that angle of refraction. We represent it by like this: angle of incidence, this angle of incidence, and this is angle of refraction. Okay. Now, what will happen if the role changes? If the medium changes, we got reversed, like light incident from denser medium to rarer medium, because this can also happen. So what will happen if that air comes down and glass comes up? If this become denser medium and this become rarer medium, when light incident from denser medium to rarer medium, the light or the refracted ray moves away from the normal. It just goes like this. It will not go like this. Okay, it will just move there. Now this is the refraction. Now we'll understand some other topics too. Now, if this is the interface, if a light is incidenting like this, okay, and also refracting like this, so in this case, is it refraction? Most people think that it is not, but it is refraction also. Why? Because medium is changing. This is interface, I told you what is interface. So this is medium 1, this is medium 2. This is also refraction. Here angle of this is normal obviously, and it's coming like this. So here angle of incidence is equal to angle of refraction, and theta is 0 degree here. This is also refraction because medium is changing, light is traveling from one medium to other medium, but it is not refracting like that, but it is refraction, and this phenomenon is called normal of incidence. Now let's move to other topic, that is we'll talk about some angle of deviation. Now what is angle of deviation? I will explain that thing to you. Now angle of deviation. For here, this is the incident ray. Okay, this is I. Now this is the whole normal here, and let's suppose it is rare medium, and this is denser medium. Medium 1 and medium 2. Obviously it is denser, so it will move towards the normal, and this is the refracted ray. This will make angle of refraction. Now, what is angle of deviation? See here, the incident ray should have gone like this if the medium has not changed. So angle between the actual refracted ray and between the accepted ray is called angle of deviation, and it is represented by delta, that is a Greek letter. Now if we will write formula, so we'll think like this. This is vertically opposite angle, so it is equal to each other, but we have to take out what is angle of deviation. So in simple words, angle of deviation would be equal to angle of incidence minus angle of refraction. If opposite will happen, then it will be like this, angle of refraction minus angle of incidence. So these both things are same, nothing major problem in it. Now we'll move to other topic, that is refractive index. Before that, we have to understand light speed. Now we should know what is the speed of light, and after that we should understand some wave properties or wave characteristics of light. So light speed, we already know that it is speed of light. What is speed of light? Speed of light, which is represented by c letter, small c, is 3 into 10 raised to power 8 meter per second in vacuum or air. Now, light has two wave characters. One is wavelength, which is represented by lambda, and other is frequency, which is represented by nu. So we know a formula which relate all these three things, and that is c is equal to lambda nu. That is speed of light is equal to wavelength into frequency. When medium changes while traveling of light, when the light is traveling a path and the medium changes, so speed of light also changes. Wavelength also changes, but frequency remains the same. Frequency remains the constant. Now what is refractive index? Refractive index is represented by mu, and it is, in simple words, it is speed of light in vacuum or air and speed of light in any medium which is given to us. So this is called refractive index, and it has no unit. And after that we have to understand, and this is called absolute refractive index. Now what is relative refractive index? It is when speed of light in medium 1, speed of light in medium 2, and that will be represented like this. It also has no unit. And after that we will understand the two laws of refraction. The first law of refraction is very simple. We already know. We have studied it right now. And second law is little bit new. The first law is that incident ray, normal, and refracted ray all lies in same plane. Obviously it is lying in the same plane. So first law we have done already right now. And the second law is It is also known by the name of Snell's law. In simple word, it is the product of refractive index and angle of sine of incidence, that is sine I, and it is equal to constant, that is mu sine r. If we write it more carefully, it will be like this: sine I upon sine r, which is equal to mu 2 by mu 1. Somewhere in books it is also written like this: sine. If we take mu 1 in air, refractive index in air, then it will be 1 obviously, and it will be equal to mu 2 sine r. So it will be written like this: sine I upon sine r is equal to mu. So no major problem, no major difference, it's the same thing. So this is the laws of refraction, and we are done with this. Thank you.